Hi there, this is Ms. Page, and in this lesson we're going to talk about the key features of polynomial functions using the graph of a polynomial function. We have done many of these before, if not all of them, with our quadratic functions. And our quadratic functions, which graph as parabolas, they are also a type of polynomial function, x squared polynomial functions. So we've talked about zeros, which we find as values of x that are found at points where we cross the x-axis. We've talked about a vertex, which being either a maximum or a minimum, in this case is a maximum because it's the high point. We've talked about intervals where a function increases or decreases. So here the function is increasing here, and that goes from negative infinity to the x value of -1, which is this interval, and then it decreases after that. So it starts decreasing after -1 all the way to positive infinity. So remember, these intervals are all about x. And we've talked about end behavior for a function. End behavior is what the function is doing as x goes to positive infinity or negative infinity. So here we see as x goes to negative infinity, the function is heading down, so the function values are going to negative infinity. Those are our y's. And as x goes to positive infinity, over on the right side, we see the function is also heading down, which means that the function values there are also going to negative infinity. All right, so one of the things about higher degree polynomial functions is that they can have more than one maximum and or minimum. They can have both a maximum and a minimum. It depends on the degree of the function and the type of function that we're working with. And so we want to talk about the idea of maximums and minimums in terms of what we call relative maximums, relative minimums, or absolutes. So relative means that it is the maximum or minimum on a certain interval, but it's not the overall maximum or minimum for the function. So here we have a relative maximum, a relative high point in the interval, basically this interval up to this point. This point right here would be a relative minimum on that interval. This point is both a relative maximum on a given interval. It's also the absolute maximum for the function, meaning that it is the highest point the function ever reaches, or the highest y value that the function ever reaches is located at that point. Then we have another relative minimum. Notice it's also a zero. So zeros, you want to be on the lookout for those things in this lesson and in these types of problems, that zeros can also be relative minimums and maximums. And then we have another relative maximum here. There is no relative or absolute minimum for this function because the end behavior heads down to negative infinity on both ends, so it never reaches a low point because it keeps going to negative infinity. All right, so we're going to break this lesson up in our examples. We're first going to talk just about zeros, relative maximums, and relative minimums for our examples. So here we're looking for zeros. So remember, we want to focus on our x-axis and any point where our function intersects our x-axis. The zeros, remember, are not the points. We would refer to those as x-intercepts, but the zeros are the x values that create those y's of 0. So we have two zeros, one at -3 and another at +4. Relative maximums now. We're now looking for where we have high points on our function. And so we're looking for little mountains or little hills. And here we find a little hill. So this is a relative maximum right here. And it is the entire point. So here we have a relative maximum at 2.25, 6077. Now we're looking for relative minimums, which would occur if we have like a bowl shape, all right? And we don't have any bowl shapes. This point right here, which is our 0 at -3, is a point of inflection where it changes from a hill to a bowl type shape, so that one doesn't count as a minimum. So we don't have any true bowls with a bottom point, so there are no relative minimums. So we would say just none in this case. For our second example with these three key features, so here we're looking at our zeros. So again, we want to focus on our x-axis. So we have 3 points where the function is on the x-axis or crosses the x-axis, and the x values for those points are -5, 2, and 7. So we have 3 zeros, -5, comma, +2, and +7. Relative maximums and relative minimums. So in this case, maximums, again, we're looking for high points. So here we find one here. So this is a relative maximum, and we find another one right here. So this is a second relative maximum. So we have 2 points, -1.8, comma 650.8, and a second relative maximum point at 5.6, comma 1019.1. Relative minimums, which again are low points at the bottom of like a little bowl or valley, we find that here and here. These are also both zeros, but as relative minimums, we'd use the entire ordered pair. So we have relative minimums at -5, comma 0, and also at +2, comma 0. All right. Here's a practice problem. Give these three things a try for this example. Pause the video, and then we'll take a look at the results. All right, let's take a look and see how we did. So the zeros are at -5, +2, and +7. There is one relative maximum right here at 2, 0, which is also a 0 of 2. And then we have relative minimums both here and here. So 2 relative minimums. Here's a second practice problem. Pause the video and try this one, please. All right, let's take a look at the results. So here we actually have 4 zeros. We cross the x-axis here, 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 and here. The x values are -2, 0, 6, and 10. That's what we see here. And then relative maximums, we have 2. We have one here at the top of a hill, and we have a second one here that was also a 0, and that would be our 6, 0 as a relative maximum. Relative minimums, we have 2, bottom of a bowl here and there. All right, moving on. So the next key feature we want to talk about is intervals where a function is increasing or decreasing. And so we're looking for where things change. And with polynomial functions of higher degree, a lot of different things can happen. So a function changes from increasing to decreasing or from decreasing to increasing at the x values of relative maximums and minimums. So it changes increasing, decreasing, or decreasing to increasing at relative maximums and minimums. So what we need to do is locate those points and pay attention to those x values. So here we see the function is decreasing until it hits this x value. And then it increases until it hits this x value. And then it decreases again until it hits that x. And then it continues to increase until positive infinity. Over here, it is this one is for positive and negative. So now when we're looking at where a function changes from positive to negative or negative to positive. So positive intervals are when the function is above the x-axis. Negative is for any portion of the function that is below the x-axis. Here we have to realize positive and negative, since it's above and below the x-axis, are going to change from one to the other at the zeros of the function. So here, this piece of the function is positive for x's from -infinity to this x here. And it's then negative from this x to this x. It's then again positive from this x to this x. And then it is negative again from x to x. And then it is positive from this x all the way to positive infinity. So here's what you're looking at. Increasing and decreasing intervals change at x coordinates of maximums and minimums. Positive and negative intervals change at the zeros. Those are the key things we have to keep straight. All right, going back to our first example now, we're going to look at our increasing and decreasing intervals. All right, so what I like to do for these problems is mark on my graph whenever possible the sections that are increasing or decreasing, and then positive and negative. So we're going to do increasing and decreasing first. Notice here we're doing the decreasing interval first, and then we're going to do the increasing interval as far as the lines here go. So we have to make sure we're keeping track of that. Remember, we do increasing, decreasing always from left to right. So I'm following my function, and it is heading up, continues to head up. So this is all an increasing section. It then changes to decreasing. Try that again. There it goes. So now it is decreasing here. Now you got to remember that when you're doing this, that you're looking at x values, all right? And so you're focusing on your x values, your x-axis. You always start from negative infinity, and then we're changing at this x value. And then from there to positive infinity is where we have this decreasing section. So our increasing interval is from negative infinity to 2.25. That would be this one, negative infinity to 2.25. Our decreasing interval starts at 2.25 and goes all the way to positive infinity, like so. All right, positive and negative. So now we got to shift our thinking. So positive and negative is, positive, remember, is above the x-axis. That would be this section right here. So all of this, all of these y values are all positive because they are above the x-axis. So those positive y's occur from the x here of -3, which is a 0, to this x of 4, which is also a 0. So our positive interval is from an x of -3 to an x of positive 4. The function is negative, has negative y values here where it's below the x-axis, which would be from negative infinity to -3. So that's one negative interval. And then we have a second negative interval that starts here at the 0 of 4, and notice this is a negative section here, so these are both negative, and it starts at 4 and goes until x is positive infinity. All these negative y's correspond to these x's. So we have in union with the interval from positive 4 to positive infinity. All right, let's take a look at our second example for these key features. So again, I'm going to do our decreasing and increasing first. So I'm going left to right here. So here I start at the far left and my function is heading down. So that's a decreasing section. Those x's for those decreasing y's would go from negative infinity to this relative minimum value, x value of -5. So from negative decreasing interval, so negative infinity to -5. Then I hit an increasing interval, and it increases here. So this is increasing. And it goes from this minimum x value of -5, and it stops increasing at this maximum x value of -1.8. So that's an increasing interval. So my first increasing interval is from -5 to -1.8. Then it starts to decrease again. Stops decreasing right there at that minimum. So it's decreasing from -1.8 to +2. So decreasing again in union with the interval from negative 1.8 to positive 2. Then it starts to increase again. So it increases on this section. So it increases from the x of 2 to the x of 5.6. So on our increasing, we have in union with from the interval of 2 to 5.6. And then after that, it decreases the rest of the way. So it's decreasing from this x of 5.6 all the way to an x of positive infinity. So that's our third decreasing interval in union with the interval from 5.6 to infinity. All right, so positive and negative. So positive and negative, I'm looking at sections that are above and below the x-axis. This one's a little different for positive. I'm going to go left to right again. This section right here is a positive section because this is all above the x-axis here. So here's my x-axis, and this is all above. So that's a positive section right there. And so these values are positive from our negative infinity to negative 5, which is a 0 in this case. But then notice it's that 0 is also a relative minimum, so then it bounces back up. So it's still positive. And so this section is a second positive. Now the reason we cannot combine these two together is because 0, remember, which is this y value, is not a positive number. So we're not above the x-axis here. We're on the x-axis, so it doesn't count as positive. So that actually creates two separate positive intervals separated by that 0 right there. So here, our second positive interval goes from negative 5 to positive 2. So in union with from negative 5 to positive 2. And then it does it again. So here at this 0, it bounces back up. So this is a third positive section. And this positive section goes from the 0 of 2 to the 0 of 7. So in union with the interval from 2 to 7. We only have one negative interval. Negative interval starts here. This section right here is the only negative section. So those negative values correspond to x's from the 0 of 7 all the way to an x of positive infinity. So that's our only negative interval. All right, let's try a practice problem. So to do these, pause your video and then we'll see about the results. All right, let's take a look. So for increasing and decreasing, you've got your decreasing intervals. So it's decreasing all on this section. And then it increases on from negative 3 to 2. Decreases again from 2 to 5.5. And then it increases the rest of the way from 5.5 to an x of positive infinity. So starts at negative infinity for x. And decreases until an x of negative 3. Then it increases from negative 3 to 2. Then it decreases again from 2 to 5.5. And then it increases from 5.5 to positive infinity. Positive and negative intervals. So for those, we are looking at, for our positive intervals, so here's a section that's above the x-axis. That goes from negative infinity to negative 5. Then we're below the x-axis, so that's a negative interval from negative 5 to 2. That's this one. Then it's below again, so it's a second negative interval from 2 to 7. That one right there. And then it goes up again, and now we have this positive interval from 7 to positive infinity. And that's that one right there. All right, second practice problem. Again, do those key features. Pause your video. All right, let's take a look. All right, so increasing, decreasing, again, going left to right. So it starts off here and is increasing. This is an increasing section. So it's increasing from an x of negative infinity to an x of negative 1.1. That's this section right here. Then it decreases on this section, and it decreases from negative 1.1 to 2.2. That's that one. Then it increases again from 2.2 to 6. That's that one. And then it decreases again from 6 to 8.8. That's that one. And then the last section, it is an increasing section from the 8.8 all the way to an x of positive infinity. Positive and negative intervals. So our positive and negative, going left to right, this is a negative interval right here. And it's negative for x's from negative infinity to this x right here, which is negative 2. Then, and that's this one right here. Then we're positive above the x-axis from negative 2 to 0. That's that one. Then we're below the x-axis again. So this is another negative interval from 0 to 6. That's that one. Then it bounces down. So it's another negative interval from 6 to 10. That's that one. And then finally it goes up again above the x-axis for a final positive interval from an x of 10 to an x of positive infinity. All right. Now, next key feature is end behavior. And we're looking at this in terms of our parabolas, two separate parabolas here for reference. So end behavior, remember, is always looking at as x goes to negative infinity and as x goes to positive infinity for our polynomial functions. And then the f of x or y part is describing what the function is doing. So this is our x of negative infinity, that's our left side. This is our x of positive infinity, our right side. This is our y or f of x of positive infinity. That would be this end and that end. And this is our y of negative infinity as we head down. So this end right here, as x goes to negative infinity, y goes to positive infinity. This end, as x goes to positive infinity, y goes to positive infinity. This is a left end, so we're looking at as x goes to negative infinity, y goes to negative infinity. And at this end over here, we're looking at, okay, we're on the right side, so x goes to positive infinity and y goes to negative infinity, which is this over here. All right, let's take a look at the end behavior here for our first example. So one of the things, if you've had trouble with end behavior in the past, that I recommend you do is mark your x and your y axes and write your infinities. So this is x at negative infinity. This is x at positive infinity. This is y at positive infinity. This is y at negative infinity. So now I'm looking over here at the left end. So the left end is x going to negative infinity. It's pointing down, so y is going to negative infinity. So for one piece, we'd say as x goes to negative infinity, our function, which is f of x, function or y values go to negative infinity. For the right end over here, so now we're on the right, so x is going to positive infinity. The function's heading down, so y's are going to negative infinity. So as x goes to positive infinity, f of x goes to negative infinity. All right, let's take a look at our second example for this key feature. All right, so again, good strategy is to put your infinities on your x and your y axis and the variables of x and y. So on the x-axis, the left side is negative infinity and the right side is positive infinity. For the y-axis, the top is our positive infinity and the bottom is our negative infinity. So now I'm looking at my left end. So for my left end, x is going to negative infinity. This time it's pointing up, so y is going to positive infinity. So I would say as x goes to negative infinity, the function f of x values, which are my y values, go to positive infinity. For my right end, so now I'm on the right end, so x is going to positive infinity. The function's pointing down, so y's are going to negative infinity. So as x goes to positive infinity, my function f of x, y values are going to negative infinity. All right, let's try a practice problem. So pause the video and do the end behavior here. All right, let's take a look. So here in this case, both ends are pointing up. So as x goes to negative infinity, that's your left end. The function is heading to positive infinity. And on the right end, as x goes to positive infinity, the function heads up again. So the function heads to positive infinity. Let's try the next practice. Pause your video. All right, let's see how you did. In this case, we have the left end and the right end. So this is our x of negative infinity, and it's pointing down. That's our y of negative infinity. So as x goes to negative infinity, the function values go to negative infinity. That's that piece right there. On the right end, that would be x going to positive infinity. It's pointing up, so that's your y is going to positive infinity. So as x goes to positive infinity, the function values go to positive infinity. All right, now we're going to put everything together for this third example. And you'll notice that in this particular problem, we don't have a bunch of ordered pairs to help us out with this. So we have to identify more from our scale and the graph what we're dealing with. So going all back to our zeros here. So I'm focusing on my x-axis and I'm scanning and I find I have a point here, I have a point there, and I have a point there. So here, this is -6 and this is -8, so that has to be -7. This is -2 and -4, so that has to be -3. And this is 2 and 4, so that has to be +3. So I have 3 zeros at -7, -3, and +3. Then I'm looking at relative maximum, so those high points, and I find that I have that here. And so this is on the y-axis, so that 8 is my y value, so that is 0,8. So I have a relative maximum at 0,8. And I'm going to look at relative minimums. So I have a relative minimum here. And so I have to realize my x would be -5 and my y would be -2. I also have a relative minimum here, which is one of my zeros, and that would be 3,0. So I have -5, -2, and, because these are points, not intervals, 3,0. Then I'm looking at decreasing and increasing intervals. So we're going left to right, decreasing and increasing. So here we are decreasing until we hit this minimum. So we're decreasing for x's from -infinity to -5. So I want to put that one here. Then I increase, and I increase until I hit this point here, which has an x of 0, remember. So from an x of -5 to an x of 0. That's an increasing section, so that goes here. So from -5 to 0. Then it decreases again over here. So this was decreasing, increasing, decreasing from an x of 0 to an x of 3. So in union with the interval from 0 to 3 for x's, we have decreasing y's. And then finally, we have a final increasing, which starts at the x of 3, or right after the x of 3, really, all the way to an x of positive infinity. So we have in union with the x interval from 3 to infinity are also y's that are getting larger. Then we're looking at positive and negative. So for positive and negative, I'm looking at above and below the x-axis. So here I have a section that's above the x-axis. So that's from -infinity to -7. Those are positive y's. Then we have a negative section here from an x of -7 to an x of -3. Then we have a positive section right here. These are all above the y-axis. And those positive y's correspond to x's between -3 and +3. So that's a positive section. So in union with from -3 to +3. And then we have another positive section because it bounces up, and those positive y's correspond to x's from positive 3 to positive infinity. So a third positive section from positive 3 to positive infinity. All right, and now we're looking at end behavior. So for end behavior, I have my ends here. So this is my left end, which would be x negative infinity. It's pointing up, so y is positive infinity. So as x goes to negative infinity, my function y values go to positive infinity. For my right end, that's x going to positive infinity. It's pointing up, so y is again going to positive infinity. So as x goes to positive infinity, my function values go to positive infinity again. All right, that is the end of this lesson. So go ahead and give your assignment a try and have a great day.